The YouTube session started as well?
Yep, we're live on YouTube.
Okay.
All the streaming platforms.
I have YouTube window on my left so I can see that we're live.
Can you give Yang the permission to turn on the video and audio?
There we go.
Ooh, I see I am a co-host. What should I be doing?
You are a panelist, so anyone who is not a co-host would not be able to share their video or unmute themselves.
Cool.
There's a bit change of the panelists due to some schedule conflicts. So I'm now a panelist, and also Jay is also another panelist.
Yep, we had like we had some conflicts and some people got sick, COVID, so we had to invite 3 other panelists.
Yeah, I actually got my roommate got not roommate. Oh yeah, I think they share the same apartment. They just got COVID. Last few days.
That's bad. Okay.
All right, we're at 10 a.m. I think. Oh, there's still a minute to go. We'll be starting pretty soon. All right. Thank you everyone for joining us. We're just getting started. Welcome to the panel on getting started with systems research. We have a lineup of fantastic panelists for our event. And we're going to be answering a bunch of questions related to how you should or like how you would get started with research, some of the basic stuff and maybe some of the advanced stuff, depending on the questions. The panel format is first 10 minutes is going to be some of the introductions about what the panel is going to be, what students at Systems is, and panelists introductions. Then we're going to move on to the curated questions that we have collected over the last few weeks. And then we're going to move on in the last 20 minutes to the questions, the live questions from the audience. For the live questions, we're going to use Slido. There's a link on the event page where you can go, or directly on the event page, you can ask questions. So moving on. I'll briefly get started with what Students at Systems is. We're an organization it's a student-led organization. We started in February of this year. We're right now 6 students from 4 different universities in the US. We're mainly focused on trying to help other students in the area of systems by organizing different events. For example, this one. Getting started with systems research is our first event. And we really hope that you enjoy this panel. Here's our list of panelists. We're really excited to have people with a wide variety of background in systems. We have the first name on our panel is Stuart Grant. He's a PhD student at UC San Diego. And I'll go through a brief introduction, and then I'll ask our panelists to introduce themselves. We also have Xiang Liu from University of Virginia. He's currently a PhD student there. He's soon going to be starting at University of Waterloo as an assistant professor. So congratulations, Xiang. We have Emily Ruppel from CMU. She's finally a PhD student there. We also have Jia from University of Rochester, who works on programming languages and security. We have Yang Zhou from Harvard University, who is a PhD student over there. So this was a quick introduction. Now I'll go in the same order and ask the panelists to introduce themselves. So Stuart.
Yeah, hey everyone. My name is Stuart. Yeah, I'm a fourth year PhD student, UC San Diego. My advisor is Alex Snoren. The majority of the work that I do is in the systems and networking division. And really what I'm working on a lot of the times is like low level networking, networking programming. So things like SmartNICs, P4 switches, RDMA NICs. And I do a lot of this in the context of resource disaggregation. So yeah, if you have any questions about working with kind of exotic networking hardware, I guess I'm the guy to ask.
Awesome. Sihang.
Thanks for introduction. I'm Sihang Liu. I'm currently at Virginia working with Professor Samira Khan. And I'm so happy that I'll be joining University of Waterloo as a system professor. So my research is primarily in systems and computer architecture, in the domain of persistent memory specifically. And by the way, I'll be hiring students soon.
Awesome. Emily.
The most shameless of plugs. I love it. My name's Emily. I'm, like Suyash said, a graduating PhD student at Carnegie Mellon. I'll be working at Bosch Research, still in Pittsburgh, as of summer. So that's what's next for me. But my research is primarily kind of a combination between embedded systems and programming languages. Specifically, we look at how to make it easier to write code for devices that run with capacitors or supercapacitors in place of batteries. So it just opens up a new execution model that we try to make more manageable. Oh, my advisor is Brandon Lucia. So.
That's pretty cool. And congratulations on your job. Gia.
Hi, I'm Jie Zhou. I'm a final year PhD student at the University of Rochester. I work on software and system security, and mainly focus on low-level securities of the software system. And I'm generally interested in compilers and programming language. And I saw that maybe most of the system people are focusing on performance, but don't forget there are security problems.
That is true. Yeah, thank you. Yang, please go ahead.
Yeah, hi everyone. Thanks for organizing this panelist. So I'm Yang Zhou. I'm from Harvard. I'm fourth year, and I work with two professors. First is Minlan Yu, who is in some networking community, and also work with another professor, James Meekins, who is in the security community, and also system. So basically my research covered two topics: the security. I did some research on like SmartNIC security, and some like systems and networking, like remote memory and disaggregated compute and memory, those stuff. Yeah.
Awesome. So we're a diverse group of people with different areas in systems. Thank you for introducing yourselves. Next, behind the scenes, Yuying Li, she's a PhD student at Cornell, and Jishan Wang, who's a PhD student at UC San Diego, are going to be moderating this event. Thank you for doing that. And thank you for all the members of all the panelists and members of Students and Systems for making this happen. So next we'll move on. It's good that we started on time to the curated questions. I'll share a question, we've divided the questions into several categories, and we have a couple of questions in each category. We're going to be sharing, I'm going to be sharing the questions, and we'll go through the panel and ask for their advice or opinion on like what they think about like how to approach something or how to solve a problem. Okay, so the first, I think like one of the questions that comes up often is when you're getting started with research, it could be systems research or in general, is like, how do you come up with new research ideas? How do you balance between what you want, what your advisor wants, and like just to create that balance. So starting with that theme, we have this first question here, which is like pretty basic. How do you decide on a research topic? Your advisor might have like some expertise, and you would have some personal interest. You could be an undergrad student or grad student, either way. So yeah, does anyone wants to take that?
Sure. I mean, yeah, I don't mind starting. I don't want to interrupt anyone or be awkward, but yeah. So I think that a big thing about picking a research topic is really playing to your own strengths and also kind of like understanding what will keep you interested for a long time. So at least for myself, I feel like, I mean, this is maybe in the getting motivated category as well, but if I want to pick a topic, it's something that I know that I'm going to be looking at for like probably a year, maybe 2 years, every single day. So I usually try to pick something that'll keep me relatively motivated. And then with regards to like your advisor, I'll usually ask my advisor, Alex, directly before starting anything if he thinks it's interesting. And like basically that exact same question, like, are you okay with me coming and talking to you once a week with questions in this exact area? And like, do you want to become educated and become an expert in it? And if he says no, then I usually don't pursue that topic. I think that's like, yeah, I'll let everyone else talk as well, but that's one thing I would do.
Yeah, I think I'll chime in a little bit here. Is like, at least for me personally, I started with a research topic kind of based on the project my advisor sort of handed me, like just getting going. And then from there, I try to pick projects based on like kind of an itch that comes up from the first one. So for instance, like what is a pain point that we dealt with and kind of worked around in the first project that we can solve in a more systematic way in the next project? Because that is the fun of systems research, is like the goal here is to build a thing that works. And there's infinite pain points when you start to involve any degree of engineering in it. So.
Yeah, just follow-up comments, also share some of my experience. So I agree with Stu that the personal interest is definitely important. It has to be something that interests me, but at the same time, listen to advisor's advice because he or she most probably be more experienced than you are. So if there's something that doesn't seem to work out from their perspective, probably not a very good idea to pursue. But before that, I would say show enough evidence that the project that you are thinking about is gonna work, to convince your advisor, this is something I really work on. Do you think it's gonna work? If yes, then go for it. So my experience is, so I basically started the research area of persistent memory following my past research when I was undergrad at Michigan. And fortunately, my advisor from Virginia is also a memory person. So I just proposed to her that I want to work on persistent memory systems. And seems like security plus persistent memory will be an interesting topic. What do you think? So I prepared the slides and say, here are the challenges that people haven't solved. What do you think? Then it's turned out to be quite successful in the end, that things work out. But I guess one important thing here that I want to share is always be prepared before meeting the professor, so that he or she will not say, this thing doesn't seem to work up front, but instead you convince them to get approval on continuing the project.
Yeah, so I think if you already have some experience like Zihang, when you started the PhD, sure, you can pick your project, but don't worry if you don't know what to work on, because in the first 1 year or 2 year, chances your advisor will give you something to work on. And from my experience, it doesn't matter that much what exactly you are working on, because in the first few years, you are building your skills, which will be used for anything later. So just start to work on something and stop, spending too much time thinking about what I will be working on. You may need to do that later in your PhD, but in the first 1 or 2 years, just working as a auxiliary person in a group, that is perfectly fine, I think. So don't worry about it.
Awesome. I think like the gist is that you want to try different things and then trying to find what your strengths are. And it's perfectly okay if you want to just worked with someone else who is like working on an existing research
Yeah,
project.
you will find what you really like while you are working on something maybe not very interesting to you in the first place. You can, anything can spin out during the process.
Yeah, to follow up on that, I think it's important to remain curious, even if you're, just helping with a project. As long as, like G said, as long as you're building your skills and you're staying curious about the different parts of this project, it can help to lead to fruitful research directions for yourself later on.
Yeah.
Exactly. Yeah. That was like I think it was pretty comprehensive and helpful response. Next, moving on to the next question is like, how do you find topics that interest you and your advisor? I think it sort of touches on the same theme, but if our panelists have some concrete like examples of how they figure out what they want to work on when they started the PhD or when they started their undergrad, I guess, or master's degree. Some of their experiences that you had would be helpful.
I have a short answer for the first half of the question, but for the later half, that'll be much difficult. So for the first half, find something that interests you, just read more papers, or read more works. So you will find something. There are so many problems that remains unsolved or are not solved very well. You will definitely find something that interests you. But the second part, I tried several times to persuade my advisor to work on something. Although finally he agreed, but I don't find the process very, interesting. It might be very difficult to persuade your advisor to work on something that you haven't started, because there are so many questions your advisor would ask you, and since you are not starting working on this problem, you may not have the answers yourself. So you see this, you kind of end up in this chicken egg problem. So my experience, it's harder to persuade your advisors to do something. But I think what you can do is focus on the first half.
Okay, so I just want to share some of my experience. So when I start my first year, it's basically in my lab. My advisor normally gives you some few ideas that she feels interesting, and you can pick them. And once you get senior, you want to do your second project, and you need to propose some topics, some ideas. So my advisor, they normally prefer some idea that doing some new problem that hadn't been solved or like proposed by prior paper. And if you really want to do some like maybe performance squeezing, improve some existing system performance, she normally would like to have some like maybe like spending on 1 month, 2 months, you can see some results coming up quickly. That's her style. Basically she would like some new problem that if you can find them. Yeah.
Cool. Yeah. That is really good point. I think an important part of getting started with research is that you want to do literature review of all the existing research, so that you know what's going on and what you want to improve on. All right. This completes our first theme, and we'll move on to the next category of questions that we have. So another topic that often like students struggle from is like, how do you stay motivated especially in projects and systems which are really long, like could last a couple of years. So the first question is like, what motivates you, like when you're choosing a project or when you're actually working on a project, and especially when these projects are really long, what things you do, or like what you do when choosing a project, and that helped you remain motivated during the entire duration of the project?
Yeah, I think that similar to what I said before, like you kind of want to know yourself really well before choosing a project. And like you can only get that from a little bit of experience. But if you've done something that already took you like 1 or 2 years, you can ask yourself the question, like, what kept me motivated during that last thing? And is that same motivating factor going to be around for this next project? I think one thing that's kind of like off to the side that I do to keep myself very motivated is just like exercising a lot, because it's very good for your mental health. And so I think that that's a thing that maybe doesn't get talked about a lot as part of just like staying motivated on a project, is just being like healthy so that you can come in every day. And if you're stuck on like a bug that's been like 2 weeks and your program's like still seg faulting and you're like, oh my goodness, I just want to quit this thing. Being like, nope, I've still got like, the capacity to push on this for another like 3 hours today. And then maybe even having like a little side project, so that like if the stress becomes too much on like the main thing that you're doing, just having something so that you can have like a checkbox ticked at the end of the day and feel like you've made some progress. I think that that's kind of nice. And so I usually have something really hardcore that I'm like writing in C that's like directly touching devices, and then like some Python stuff that I'm doing off to the side that's much easier.
I want to also add on the staying mentally healthy. So my advice will be find some hobbies especially long projects. Don't get stuck with the research all the time. So like go outside for photography, go hiking, walk around in the campus, go to the bar with your friend. Those definitely help. At the end, like PhD is a long-term process. Probably not only one project, but also many other projects. So finding a way to stay healthy, motivated is definitely very critical, as important as doing research, in my opinion.
Yeah, I have a few tips, very specific tips. So the thing I did after I submit a paper, I normally go a national park for a trip for 1 week or like half a week. That's something that motivates me when I try to pushing my project for like 1 year or 2 years. Like you have a really nice trip after each submission, not necessarily like got accepted. That's a few experiences of mine.
Yeah, I definitely agree with that. Always plan to do something after a submission. Don't be like, I'm going to work 3 months, submit, and then the next day go back hard and do like another 12-hour day on another project. That's going to burn you out really fast.
And moreover, if you look at it, it probably won't work. I feel I've done like my usual, like, because I do embedded systems work, so a lot of times the lab is a literal wreck after a submission. So like my Zen like day after a submission is show up at noon and like clean the lab for a couple hours, say hi to all the people I've been like avoiding making eye contact with, like to et cetera, and like just chill. I do think on that topic, for what motivates you, it's like it's going back to what Stuart said, is like figure out that piece that you can default to. Like for me, that's building stuff. So it's like, okay, I know I can look forward to building this like system, and that's going to be kind of mindless and enjoyable for me. And then I can look forward to those steps as I'm like dealing with debugging the whole thing.
Awesome.
And also I'd like to add up a little bit. Just break up the large project into smaller goals during the process, and you cannot achieve, especially in system. We know some projects take 1 year, 2 years, or even 3 years. So don't just think about the overall project. Focus on the small steps during the process, and you will get the sense of success when you achieve it little by little.
Oh yeah, I think I'd like to even touch on that. I think sometimes also even understanding what success in systems means is a little bit different, because I remember when I started, I was beating myself to death because I couldn't get a setup working. And it was like, exactly. I didn't have I wanted to get all these benchmarks done, and I'm like, how am I going to complete this thing? I can't believe I haven't made any progress. And meanwhile, getting the thing to run or even like start is sometimes like a 2-month process, and you need to be ready to like accept that that's huge progress. Just getting
that's what I mean. Even if you put this as on your list as just make the process compile, that might not be easy. And if you can get that done, you may have already solved a very challenging problem in modern computer systems.
That is very true. I remember my days with Gen 5. Took me a couple of weeks to get it to compile. I guess like the takeaway is that you would want to pace yourself while doing your research, and in general in life, grand schemes of things. Not overwork yourself and take breaks. Stay healthy. Maybe go out, like do exercise and stuff. Stuart, actually, I think you run the running club at UCSD-CSU, right?
I don't run the running club. That's a guy named Zach Blanco, but I do co-run it with him. So I basically organize when he's not around. And yeah, we got like 7 CS students to go run a half marathon like 3 weeks ago. So that was pretty impressive, actually. I don't think it's super common to have that happen.
That's pretty cool. Moving on to the next question. Are there any challenges that you faced during your work? Any specific challenges where you felt like this is really hard? And if there are any examples that you would want to share where you overcame that challenges, and like any takeaways that you had from that experience that you would want to share?
I can get started. So one of the challenge I've been feeling is it's not only the completion of the project, but also getting published. So as PhD, you have to get sufficient publications to graduate. So I have experience at some projects and seemingly never being accepted by the community during the submissions. So I think that's the major challenge I've been facing during my PhD. So I'm thinking about there are 2 possible ways to overcome it. Or I guess there are two kind of categories regarding the failing in submission. One of them is, seems that the idea is very new, but the community is not going to, we are not showing enough work to convince the community to accept it. So in that case, I would just continue moving forward, try to get the work done, do all the experiments necessary to convince people to accept this work. Because it's new, and it also has value. So should keep going on. And the other side, if the project is not going in the right direction, for example, or it's not sufficient to be a top tier work, then I guess a better way is just to go for a lower tier conference or just stop the project in the middle if it doesn't show enough chance of getting accepted. I'm pretty sure other panelists will have similar experience. Maybe add on that.
I don't have a good answer to this. This is too hard a question. I don't want to sound too negative, but sometimes you have to give up. Chances are that you may not meet such challenging problems. I mean, something that will never work out. But there is still a chance you will, run into a dead end. And sometimes giving up might be the best choice instead of keeping going on. That's hard, but I had such experience, and I saw other students had such experience. And looking back, it might be better if we give up earlier.
Yeah, that is like something people talk as about the sunken cost fallacy. Emily, do you want to share something?
I was going to say, just to add on to the sunk cost fallacy and like attempt to spin it in a slightly more positive light, is like I had a project like that I did just like tons and tons of measurements on an embedded system, trying to get results that made sense. Ultimately, we presented these results that weren't impressive, and quite frankly, they weren't that new. But I learned a lot in the process, and that informed the next paper we tried to write. So like, even though it may turn into a graph that just gets dumped in your thesis because like it never actually, like, it wasn't top tier publication quality, hopefully you can take stuff from it and inform your next project, or at the very least figure out like what you're lacking. Because I think for me, it was a little eye-opening. It was like, oh, okay, I need more like advice in this one corner of, systems in order to make this work. I need to go look for a mentor in this or that. Like, try to use it as a learning experience, because like everyone here has said, it will happen. So the more you can take away from it, the better off you'll be.
Yeah, that is a really good point.
Yeah, I can add a little bit there as well. Just like, just like a very specific challenge that I had to overcome at one point. And I think it's something that a lot of people have felt, which is just like results not making sense. This is like a thing that I think a lot of people, when they try to do their benchmarks or even just like get their systems running for the first few times, they'll have like a specification that says it should perform a certain way, and then it just simply doesn't. And like I had an example where we had hooked up some experimental SmartNICs to a machine, and we were just trying to pass packets through it. And we had been playing with this device called an IOMMU, which is kind of a finicky thing. And after like literally an entire month of trying to get these benchmarks to make sense, they didn't. And like we were just gonna this was like one of those moments where it was like, are we gonna trash this project? Like we're like 25 gigabit below where we should be. Like it's just not working. And so like how to overcome this, we actually sent an email to an individual that had done some PCIe benchmarking and just asked for counsel, like just a random person on a paper that was doing something kind of similar to us. And they were super helpful. It was just the first author. He sent us back an explanation that was pretty funny, actually. He basically said, have you tried using a different machine? And we were like, no, we haven't. And then we switched to just another server and the problem went away, which is not very satisfying from an intellectual perspective. But sometimes that's actually what it takes, is maybe just talking to somebody who's also experienced a similar challenge.
That's a really, really good story. I think like it's often helpful to take a step back and look at things from like a different perspective. So moving on to the next category, we have on managing time, managing collaborations with people, and managing expectations. So the first question is, I guess we did touch on this a little bit, like when do you stop? How do you figure out like this thing is not working and you should move on to something different?
Well, you can try to submit a paper, and if it's rejected partially, then you can stop. Well, not the first time, maybe 2 or 3 times.
I would say so this is definitely one good sign that the community is against this idea. Probably not a good idea to push forward. But I would say another way is to see other people's feedback in the beginning while brainstorming, for example. Like I have a fancy idea. It seems like nobody has done this. So why not talk to people in this area, talk to experts. First talk to an advisor, of course, then talk to other experts, talk to mentors, see what people think about it. If there's a positive feedback on the project, probably a good idea to go forward. But if everyone is against it, I wouldn't go too deep into that.
I have a relatively complicated answer for this. I actually asked all my coworkers this question because I thought it was the second hardest one on the curated questions. And so we came up with the easiest answer is if you have a counterexample. You know, like you can definitively prove that what you're doing doesn't work. That's the easiest. And I think that one sort of layer harder than that is literally just when the implementation cost might be too high. And so I had a friend who spent actually an entire year working inside of Spark, trying to make it RDMA-able, just so that the address space was like actually reachable by RDMA. And then eventually came to the conclusion that, you know, even after all the work he had done, he was maybe going to see like a 30% performance boost. And he could probably get even better than that if he went in and started like playing around with like RDMA device drivers. But that was another total black box. And then according to his benchmarks, it was like maybe he could get 75% improvement at that point. And it's like that was the moment where he trashed the project, because it was going to be like 2 years for a result that wasn't going to blow anyone's mind. And so I think that implementation cost is really like something that you need to consider, because you only have a few years. So if you're just going to take 2 to do something that's like not going to be that big of a win, I think that can be pretty expensive. And another one's actually very similar to what I said, which is just reaching out. So I have a friend in the theory department, and she started working on a long-standing problem with a friend that had was just way too hard. But they didn't know how hard it was until they actually reached out to people who had just worked in that space. prior to them. And they were like, oh yeah, we stopped working on this back in like 2017 because it was just way too much. And we didn't even feel like doing like the work to just finish up what we had done because it was so labor intensive. And so I think that there's like a lot of stopping criteria, but yeah, just to summarize, it's like, counterexample, implementation being far too expensive, and then other people who are more expert than you going, this is way too much, and we stopped when we were further along than you were.
Yeah, I definitely agree with Stuart, the last point. I have had some experience with that too. So if you are working on something which involves an area you are not particularly familiar with, and your advisor is also not an expert in. For example, you are working on some OS stuff, but you want to make some architecture changes, or you would have to hold some deep assumption about some architecture behaviors, then you better ask some real architecture expert before you put all the efforts on. I still remember from one of the professors from my computer architecture class, and in 2018 when the Spectre attacks come out, and it's pretty hot, and so many papers, so many people working on it, and that professor told us in the class saying all the software people making assumptions about hardware, and half of them are wrong. So this is really important. So ask other people's, ask the real expert's opinion before you move on, instead of make your own assumption.
Yeah, I definitely agree on that point. I'll go ahead.
No, sorry. Yeah, if you want to share your opinion, please go ahead.
Yeah. Just a few tips. I have some like a collaborator that working on some video streaming, and every time they submit some NSDLC account, they just review said there's another paper you should compare with, and then finally he decided to drop that project merely because there are a lot of system paper you need to compare regarding your current project. And finally, his experience is saying you should reach out to some expert, or let your advisor reach out to some expert if your advisor know more people. Maybe like just when your advisor at some conference meeting with some professors, you should just let them to random talk this project, and maybe some other people will have more input into that project.
Yeah, that is a really good point. Research is not really anything that you do solo anymore, like 1700s, like when you sit under a tree and like figure out stuff. Collaboration is really, really important. That was really, really helpful answers. Moving on to the next question. How do you manage multiple projects at the same time? For example, you might be working on something and you already have another project submitted to a conference, or you're collaborating with people. How do you manage that? How do you manage time? How do you manage your headspace to, like, you get started with the project and then you have to switch? That takes up a lot of energy. So do you have any tips? Should people not do this, or any experience that you might have?
So I can start on this one. I think, like, first and foremost, it's a little bit, you basically need to make an internal calendar, or I use Google Calendar, like whatever it takes, to make sure that you know what the deadlines are for each phase of each project. So for instance, I was working on one project that had a submission to AskPLOS last August. But at the same time, I was working on another project that needed to have a certain component ready to build, so a certain PCB ready to build by like 2 weeks after AskPLOS. So I needed to make sure that I built the one component. So it was a PCB. I needed to design the PCB and ship it out to be fab, because there's a lag time there. I didn't want to do this before the AskPLOS deadline, but it needed to happen in order to get all of these things moving along. So I think it's important to map out in advance what the phases are that are going to gate each project, and make sure that you don't end up artificially delaying one because you ended up, your poor time management meant you spent your entire August working on AskPLOS kind of deal. So being cognizant of that before you really spend time on either one is important.
Yeah, that is really true. I guess like the takeaway is you would want to manage your time, figure out like how to figure out how you spend, you want to plan how you spend your time. to be most effective. Since we're getting close to the end of this part, we'll move on to the next question, which is, how do you avoid conflicts when you're collaborating? For example, you're collaborating with people that have a slightly different area of expertise, and oftentimes it happens that your ideas would be at odds with theirs. How do you figure out, how do you solve this? Because like at the end of the day, the project is going to go in only one direction. Siyoung, do you want to take this question?
Sorry, did you say me?
If you have something to share, we'd be happy to hear.
Well, I was just, I mean, this is a very difficult question. I think it's like per person, really, because some people are very conflict oriented and they're just very hard to work with. And then you need to be like a lot more cognizant and maybe like stand your ground-ish. But then there's other people who are like very amenable to like, you know, taking on your ideas. And then it's maybe the other side where you want to be like more open to that and be like, oh, like what's your thoughts here? And so I think that really understanding the people you're working with is probably the best way to deal with conflicts. And so like, and some people like require a lot of encouragement too. Like they're thinking constantly, but they may not be saying things. And so sometimes you might even be like conflicting with somebody that you didn't even realize. And like it's sort of building up inside of them. So it's like important to ask a lot of the times, like, are you okay with this? Like we just decided that section 3 is very different than what you had been working on. And I think that, yeah, I think just kind of being like on the same page with people is important, and like really sort of understanding what their motivations are so that you're not accidentally conflicting with them. And then when there are hard conflicts, I think that like almost just like straight up negotiating, being like, why do you want this? What are the benefits? And then maybe just prioritizing the science first and being like, what is the best thing that we could tell the community? And then that is kind of like a nice razor to sort of divide the conflicts, because if there's something that's maybe just like a little bit cool, but not super important, or that, you know, people will look at it and go, oh, you've just built LRU on top of this. Like we know exactly what that curve looks like. It's not very surprising. Versus something maybe totally new. And that was like the conflict that two people were having, like usability versus novelty. Maybe like then you could be like, well, the community is going to enjoy the more novel thing, and we think we're also going to get a benefit. So yeah, but yeah, I think really it's a human question, because that's sort of like being like, oh yeah, novelty is sort of the easy side of it. But understanding who you're actually working with, I think, is the real key there.
Yep, that's a good point. I think like communication is important, and also negotiating in research and in general in life. So moving on to the last topic is on internships and fellowships. And we'll probably keep it a bit short, like 5 to 7 minutes, and then we'll move on to audience's questions. So the first question is like when to start applying for fellowships. And I think this question is more geared towards PhD students who want to apply to fellowships. I know, Stuart, you got the Meta Fellowship. Congratulations. Yeah,
thanks.
So do you want to take this one? I know I've been asking you like back-to-back questions.
No, that's okay. I'm actually not very good at this. So like my advisor was like, hey, you should apply for this fellowship. And then I applied for it in my second year. Okay, so let me just think through this for a second. I mean, I think that the time that you don't apply for fellowships is if you have absolutely nothing to say. So like make sure that you've got like a project that you're working on and you're ready to like present it, and you think that it maybe has value in a way that like externally people would appreciate. And like a good way to start that is maybe like write a workshop paper. And if that gets in and people are like, this idea is really cool, then you can write a really like high level fellowship description that maybe other people will like as well. And so like second year, I think is a very good time. You've probably had some time to think and get settled and know your advisor. Yeah, So that's how that went for me. And then I just targeted Facebook directly because I figured that at some point they were going to need some disaggregation stuff. And so I wrote about disaggregation and they seemed to like it.
Yep, that's a really good point. Like figure out what you see, what you want to work on, and like find out the target companies, I guess, which would be interested in your research. Yang, do you have anything that you would like to share?
Me? Oh yeah, sure. I think so for my lab is basically we've got a first paper. My advisor will encourage you to apply for some Google Fellowship or Meta Fellowship. And I mean, my advisor normally recommend one people to apply per year, depends on like whether you have paper early or late. And then I guess that's probably when you have the first paper, then it's time to apply for some fellowship and you can write something about your future work, something. Yeah.
Yep, that's also a good point. When you figure out some parts of your research, you should start applying to fellowships. I guess we'll move on to the final question in this category, which is on internships. There are a couple of different parts, like when you want to do it, how often, and whether you want to do it in industry or academia. You're free to pick any part of this question and answer it. We'll spend some more time compared to other questions because I think this is also like something that the audience asked a lot in our source questions.
Yeah, I can share a bit more here. Mm-hmm. So I did 2 internships at VMware Research and Google. There are 2 totally different types of research group. So in VMware Research is basically research oriented. You do not need to worry too much about product. Maybe your mentor will worry about it, but you do not need to worry about it. While in Google, you need to deal with your production team, maybe directly to ask if this is really needed. I mean, even if you are doing some research, internship inside Google, you still need to face some product team, especially for system teams. And so I think both are very interesting to have, and especially from like industries, their comments are sometimes very important to you to like bypass some topic or like make you understand some topic is very important. Yeah.
Cool.
I have a short answer for this is, if you plan to be a software engineer after graduation, then I encourage you to do as many as possible as a software engineer intern. But if you want to stay in academia, then you got to be careful because it takes time and you may not gain much for your research from the internships. So yeah, that's my short answer.
Awesome.
Yeah, to follow up on that, I think it's good to do internships specifically in one of the career paths that you're considering after graduation. So like I interned with ARM Research because I was angling towards industry research to figure out if that was a fit for me. So like, I think trying to look at it through the lens of like, what does this do for my career after graduation is probably the best way is the ideal way to do it. It doesn't always work out that way just because of, things don't always work out. But I think looking at it through that lens and prioritizing it that way is helpful.
Yeah, and don't expect things will work out because you don't have much control in the project. It's not set by you.
That is true. Siang, do you want to share something from your experience? You interned at Google and you wanted to go to academia and you're going to be a professor.
Yeah, so I also agree with Jay's point. The internship takes a lot of time. If you want to go academia, probably be careful about where you're going to intern at and how often do you want to do that. But if you're going to go as a software engineer in the future, do as often as you can. For international students in the US, you have these CPT constraints. Just you utilize the entire amount, so you get better experience in the industry. Just from my experience, because I plan to go academia in the very beginning of my PhD career, so I'm trying to avoid having internship too often because that time I probably won't know much. I won't have the ability to propose anything during my internship. So most probably the project will be not aligned with my research. So if you go academia, probably do it later and do something related to your research so that it can actually be part of your future job application.
Awesome. We have got like 13 minutes left in this session, and we're gonna move on to the audience questions. So I'm gonna share my screen. I'm gonna highlight the question that we're gonna be talking about. These are all audience voted questions, and we're gonna start with the first one, which is the novelty of an idea that you're working on more important, or the performance improvements that you get more important? And I'm guessing this is more oriented toward if you want to publish a paper for the project.
Well, I have an answer for this. Actually, I asked a similar question to one of my professors, and I asked he asked me what is novelty, and I said, well, something nobody else has done before, and he said no. His answer to me is, can you make something 10 times better? For example, if you can make a system 10 times faster, nobody cares about a novelty. And of course, if you can make it 10 times faster than anybody else, you will definitely have some novelty in it. So focus on the result, focus on what you will achieve, instead of, well, if I do something that nobody else has done before, because nobody has done it, maybe because nobody cares, or somebody has tried it and failed and you don't know. So focus on the results, not the too much on the novelty side.
I want to talk a little bit in a different angle. So not every project has performance as only metric. For example, you work on security, probably.
Yes, security, yes. So performance is not the only thing, yeah.
Cool.
Yeah, but
yeah,
from
sorry,
that, can I just chime one more?
Sure, yeah.
Okay, cool. Because one more thing on that front is like, I think on one hand, performance as a metric is a way of measuring novelty, like Gia said, but like there's a reality that if you are doing research inside academia, the problem is if you shoot for performance and come up with a 20% improvement based on your simulator, it's not the same as if Facebook research does a test and they come up with 20% improvement on their like full scale cluster. So from that perspective, novelty is one angle that academia has the freedom to pursue. So if you're not testing on a warehouse scale machine, you may be better off trying to find your niche in something that's kind of weird, frankly, as opposed to going for that 20% performance improvement, because you may not have the tools to prove that it will come to fruition, like when you go to actually implement this.
Yep, that's a very good point. It depends on like if you're working on real systems, people are going to be interested in like how much raw numbers in terms of improvement you have. If you're working on architecture, what's the takeaway I have from this paper?
I also want to add on one more point. So I would say in terms of single project, proper performance is something you cannot avoid. But in the lineup of work, I would say pick up topics that's relatively new. It's not just a novelty of the solution, but also the novelty in the entire area. Like if there's new thing coming up, like when I was doing persistent memory, people haven't thought about the data recoverability when you're having security guarantees involved. Then that's, in my perspective, is a relatively new topic. So as maintaining the program to be correct from the program perspective. So performance-wise, probably will be part of metric evaluation, but just starting from the lineup of work, I guess novelty or this kind of direction will be more critical. Then when it comes down to the exact solution, performance should be one of the optimization goals.
Awesome. Well, I'm going to move on to the next question. How do you efficiently collaborate with others in systems research project? I guess the intent here is to ask, how do you find collaborators? How do you figure out like you need collaborators? Yeah,
I can take that question. So I think one of the best resources is your advisors in action, because he or she most probably will have more connections than you have as a fresh bachelor graduate. So my experience is to if I need some help in certain areas neither I or my advisor are good at, then see whether he or she knows about anybody in the field that can support us. And also, so this is mostly in the beginning getting resources from advisor. And on the other hand, I think your collaborators can also be some friends, like people you interact with in student associations, people meeting in the conferences. Those can also be good collaborators. But those things, be careful because you are working for advisor. Always ask your advisor for suggestion first.
Yeah, I think it comes back to communication. You would want to make sure you're talking to your advisor often so that they know if you're stuck on something and like if we should take if you should take help from like others that they know. Moving on to the next question. This is like I personally struggle with is like how do you, when you're writing something, how do you maintain that balance between code quality and project progress?
I have feelings about this.
Yeah, go ahead.
I think the best piece of advice I ever received about doing systems projects was that with regard to code was you make it work, then you make it fast, then you can make it beautiful. And I think in that order and no sooner. Like if your code is beautiful, but it doesn't work, what have you done, right? Like you've made no progress. And so I think like doing like little bits of prototyping and making sure that things actually function. And then like, regardless of what you're doing, you're always going to have to do an optimization stage where you speed it up. And like, it's going to look heinous, even if it looked great before, because you needed to do all kinds of wacky little fixes to make things go blistering fast. And then at the end, you know, like if you've got the paper out of it, then you can take some time and like make sure that the functions have like decent names and they've got a little comment above them. But like my code is peppered with like statements that are like, I don't know what I'm doing here, but it worked. Like the date is October 22nd, 2020. This is the commit that you come back to, like, you know, it works. Fix it at some point. And they're all still there for some reason.
Yeah, I asked the exact same question at PLDI 2020 in the Ask Me Anything session to Chris Lerner, the original author of the LLVM compiler. And his answer, I will first give his answer. His answer is, if you want to stay, if you want to go to the industry, then, you know, pay attention to the code quality. And if you want to stay in academia, then get more papers published. So move fast. So that's his answer. I don't think I completely agree with him, sort of. And my answer to this, and from my experience, is if I would give one advice is to write better and more comments for your code and write good Git commit messages, not for anybody else who will use your projects later, but for yourself, because system projects are really large. And when you're looking back the code that you wrote 3 months ago or even 1 month ago, chances are that you will not understand what you have written. So the good comments and commit messages, it helps me a lot when I was doing a very large project. So yeah, that's my, I guess, a very important advice for anyone.
Yes, for me, my only guideline is sometimes you write comments and following the Google styles of naming and formatting, and that will make your code looks better when you look at it in the next time. Yeah.
Yeah, that's I think that's really important. Someone told me during my undergrad that you write Git commits mostly for yourself. And that is, like, I found that to be true, especially in research. Maybe if you're working on Linux kernel, it's going to be important for others. But if you're working on your research project, the Git commit messages are going to be really important for yourself. All right, let's move on to the next question. This is a question on how do you distinguish between engineering component and research component in a research project. Let me paraphrase this a bit. I guess the questions, the essence is like, how do you budget time for the laborious work that you have to do in systems research, where you have to do a lot of engineering work to implement your ideas? Like, how do you know how to create that balance? I think a lot, I personally have struggled that with a lot, because a lot of project that I've done takes a huge amount of engineering effort. So how do you decide like what's worth the time? Because you cannot, it's really hard to evaluate a research idea without actually implementing something.
So I think some of this is like, to go back to the specific, like the literal phrasing of this question, is it is important to, at the get-go, define what is going to be the new part that you're working on and what is the research, what is just the engineering. And this can be hard to do if you haven't worked in this area before, because something may look like research to you, but it has already been implemented. So I think this goes back to like really doing your literature review to understand what's out there and understand like who's, you know, which giant's shoulders you can stand on, is really important. And from there, I think it goes to some of the stuff we talked about earlier, which is like, you know, the whole, when do you quit a project? It is like asking mentors for help, asking your advisor, how much implementation effort is this, could this be, to scope it out and make sure you're at least going in with your eyes open. I don't know that that precisely answers the question of the best way to do this, but the more information you have, the more you know what you're getting yourself into.
Yeah, I 100% agree with Emily on that. Like, I think another, maybe like a more empirical way to go about answering that question is like, if you're doing performance work, for instance, and you have a bar chart and you're doing a comparison between your thing and another thing, and your performance is better, just ask the exact question of like, what's the difference between what I did and what they did? And like, now I try to plan that out ahead of time. Like I actually go through my papers and like draw little fake graphs and I'm like, this is where my win is. Like, I think I'm going to get this. And then like that's what you should write about typically. And, you know, occasionally, this is probably the rare case, like something that you did in the engineering is actually so cool that you should also write about it. That happens sometimes, but I would say like in general, there's usually like, if you've organized yourself pretty well, there's like a clear path of things that you followed that other people did. And then there'll be like the thing that you did, which was new. And that's usually what's worth writing about. And hopefully it did something that impacted your results as well. If it didn't do that, then maybe reconsider if it is like an actual research component or not.
Awesome. I think we're about at the top of the hour. And this pretty much wraps up our first session. I would like to thank all the panelists for answering all these questions and helping out the fellow students in the area of systems. Thanks a lot. The recording is going to be posted on YouTube and on our Twitter channel. And we're going to collect the answers to some of the unanswered questions on Slido. We're going to be sending out to the panelists, and if they have time, we would like to hear their opinion if something they would like to add. And that is pretty much it. Thank you for joining us. And thank you once again to all the panelists.
Thanks for organizing, Suyash.
Yeah, thanks, Suyash.
Thanks.
Thank you.
Bye.
All right.